So here's that definition that I had just talked about, a set of points that are equidistant from a fixed line called the directrix and a fixed point called the focus. So they oriented this parabola in a different direction. This one happens to just be opening up. But if I measured this distance and this distance, those yellow lines would have to be the same. And if I measured this distance and this distance, those green lines would have to be the same. So every point on this parabola is equidistant from the directrix and that fixed point. And then there's two different ways that we might write our equations for a parabola. So a vertical axis of symmetry basically looks like this parabola up here, right? That has a vertical axis of symmetry. And a horizontal axis of symmetry is kind of our sideways parabola. And so the way that you write it is x minus h squared equals 4p y minus k. So the parabola equation is a little bit confusing because we've never had a p value before. H and k still have the same work. They're just the left, right, up, down. But these equations are a little bit different than anything we've worked with yet in conics. So I'll be giving you these two equations for your test. Not telling you what each part means, not telling you that it's a vertical axis of symmetry, but just getting you the correct setup. X minus h squared equals 4p y minus k, because it's just kind of a confusing equation, even for me. I don't use this equation a lot, so getting this correct format takes some thought. The p-value. So I didn't talk about the p-value, but if this green line is always the same or this yellow line is always the same, if I go right to where that vertex is, this is the p-value. So from the vertex to the focus, that's p, and from the vertex to the directrix, that's p. And then all the way across this opening, does anyone study cameras or photography? This is called the focal width. And so you might have a focal lens in photography, and you can open and close your focal lens for lighting and stuff. So this total distance across is called the 4p value, the focal width of the parabola. So we're graphing it a lot differently than we've graphed standard form or vertex form. So I'm not going to spend too much time on parabolas, but it's interesting to see it in a new light, and it allows us to graph sideways parabolas. If p is positive, then our parabola opens up. If p is negative, just like we would suspect, it would be concave down. That's if there's a vertical axis of symmetry, but we could also have sideways parabolas. So if we have a sideways horizontal parabola, it'll just be y minus k squared equals 4p x minus h. We've never had a y squared parabola before because that's not a function, right? Fails the vertical line test. And so if p is positive, our parabola will open to the right. And if p is negative, it will open to the left. So up, down, or right, left if it's a sideways parabola. So I just wanted to show you a couple examples. It's so new that you're not going to retain all this for tomorrow, but at least tomorrow will be your second look, right, through this new equation. So if I give it to you, here's the standard form right here. 8 is our 4p value, and then we've got our vertex with the x minus 3 and y plus 0 or y minus 0. Which way will this directrix go? So x squared parabolas look like this. So where's my directrix? My directrix is here, and my focal point is here. So which way is this directrix opening? It's going horizontal, right? The directrix is a horizontal line. And then if I drew my axis of symmetry is a vertical line. So those should be perpendicular to each other. And I know these are all new words, directrix and axis of symmetry, which direction it goes. The coordinate of the vertex is your HK value. So I went right 3, but I did not go up or down. So my vertex is at 3, 0, just like you find the center for your circle, ellipse, or hyperbola. So my vertex is at 3, 0. You have to find your own p-value, knowing the 4p value is 8. So if 4p equals 8, what is p by itself? Divide by 4, p is 2. Now is when you're going to graph everything else. So if I look back at this little sketch, if I go up p units, that's my focal point, and if I go down p units, that's my directrix, and p is 2. So I'm going to go up 2 and dot my focal point, and down 2 and draw in my directrix. And then this is my focal width, which needs to be 8 units long. So I'm going to share 4 and 4 on either side of my focus, so the total is 8. 1, 2, 3, 4, put an end point, 1, 2, 3, 4. So that is the width of your parabola. And those are the key points, graphing it in this form. Different than we've done in the past. Usually we went like over 1, up 1, over 2, up 4, over 3, up 9. Different format completely for a parabola. If you converted this into standard form though, it would be y equals 1/8 x minus 3 squared. This is a very narrow, wide parabola, whatever wide, less steep, right? But its vertex is at 3, 0. All right, so what's the equation of my directrix? What's the equation of this horizontal line? It's at y equals -2, right? Y equals -2, and my focus is 3, 2. 3, 2. So that's all you have to do. Those are all the steps that you would go through to graph a parabola. So that's similar to what I'll put on your unit test. I'm not going to do a whole bunch of solving with parabolas, application problems, all that stuff. We've spent so much time on the other 3. This is like, you know, I'll give you an equation like this that you'll have to answer the questions and graph it. That's enough. So let's do another one like that. So I've got x squared again on the left-hand side. So let's think about what this parabola is going to look like if there's a -16. Can someone describe what type of parabola I'm going to have? Up, down, left, or right? It's a down parabola because x is being squared, but 16 is negative. So I just like sketching for myself. My directrix would go here. My focal point goes here. It's going to look like this before I even start the problem. Now I can say the directrix is horizontal again. Axis of symmetry is vertical again, same as the first problem. Where's my vertex? 0 for x, -3 for y. So plot your vertex. To find your p-value, I always write this out. 4p is -16. P by itself, if I divide by 4, would be -4. So I know 4p and I know p by itself. Then I look back at my picture. Okay, the directrix goes above the vertex. So 1, 2, 3, 4, this is my directrix. 1, 2, 3, 4, this is my focal point. My focal width is 16. So I'm going to go 8 units and 8 units. This is a 10 by 10 grid, if that helps you, counting. And it's going to open very wide through that focal width of 16. And then you can record the equation of your directrix and the coordinate of your focus. Let's see. Equation of my directrix would be at y equals 1. And where's my focus? This was -3, 4, 5, 6, 7. So 0, -7. So could you answer all those questions based on this equation? And if you think about it, let's convert this into a standard form for ourselves. We would divide by -16, right? So I would have -1/16 x squared equals y plus 3, and then I would subtract 3. Just let's see if this makes sense from the old standpoint. This has been shifted down 3 units, flipped upside down, and is a very less steep parabola than the parent function. So it should, it's the exact same equation, just in a different format. Now I can see my a value. All right, one more. What about an example where I've got a vertical directrix, so a y-squared parabola? What is this one going to look like? Is this going to be a right or a left parabola? It has a -4. So it's going to be a left parabola. So I would just draw for yourself, okay, now I know my directrix is here and my focal point is here, so that when I'm graphing it, I know where those things go. So my directrix this time is vertical, which makes my axis of symmetry horizontal instead. Where's my vertex? X goes what and Y goes what? What'd you say your vertex is? 0, right, for X. -2 for Y. So 0, -2 is your vertex. All right, my P value, if 4P is equal to -4, P by itself is just equal to -1. So I have to go 1 unit, plot my focus, 1 unit, plot my directrix. So my focus is to the left and my directrix is to the right. I always look back at that original picture. That helps me. And then the focal width is 4. So I'm going to share 2 on one side of the focus. It's called focal width, right? So it's across from the focus. This is a little bit narrower of a parabola. And let's see, my directrix is a vertical line at 1. So I write that x equals 1. And my focus is at what? -1, -2. And there, you just graphed a parabola kind of in a new way. And then I said we were probably not going to do number 1 on the parabola practice, and see if you can answer the questions and sketch a graph, and just sketch it. It doesn't have to be exact, but could you read, the p-value if it opens up, down, left, or right, and answer the questions about the vertex, focus, directrix. So I found